Hello everyone, Brent Ritchie here. I'm going to go through our test review for the compound interest module for business math 132 here at Southside Virginia Community College. There's 15 questions we're going to work. And I'll use a calculator because that's the nature of these questions. Desktop organized. Keep in mind the compound interest formula we're going to use is the amount, final amount is the principal times 1 plus the rate over the number of periods per year times the number of periods per year times the year. So A is the final amount, will be the total amount we paid if we're borrowing the money, or the total amount we have in the bank if we're saving the money. The P is the initial principal. And R is our rate, our interest rate. N is the number of times it compounds during the year, so number of periods per year. Times per year. So if it's quarterly, that's 4 times per year. If it's monthly, it's 12. And then the T is number of time periods, and I must have all cases, and I'm pretty sure in all the ones that we're going to do, the time period is a year. So I'm just going to say the number of years here for T. Let's get started so we don't go too long. Like I said, there's 15 questions, and I'd like to hit all of them if we can. Here's question number 1. Manually calculate the compound interest on an investment of $12,500 at 7.5%. Compounded semi-annually, that's twice a year for 2 years. So writing that in our formula. Now they just want the interest on this. So we can calculate the interest with this formula and then subtract back out the principal, or there's another simpler formula, but I don't know if that's worth. I don't like to have too many formulas to remember, so I think I'm just going to go with the one I have. The amount's going to be, in this case, the principal, $12,500, 1 plus the rate, which is 7.5%, written as a decimal, looks like that, divided by the number of times it compounds per year, semi-annually, so that's twice a year, for 2 years, times 2 times a year. So that's what we get. And I'm going to get my trusty old calculator out here. We don't need that parabola. And so I've got 12,500 parenthesis. I like this Desmos calculator because I can type the whole thing in at once and I can see what I'm typing. 7.5% divided by 2. My other parenthesis raised to the 2 times 2 to the 4th power. So that gives me $14,483.13. Now that is the final amount, which includes the principal. So they're just asking for the interest. So I'll take this and subtract that 12,500 initial amount out, and I get 1983.13. 1983.13 right there. Sometimes the answers on the quiz will be off by a penny or two, especially if they use the table. If they use the table and we use the formula, our answer is actually a little more exact, but it'll be close enough where you'll be able to tell. The tables exist because pre-calculator days, they saved a lot of time. Now, I'm not sure they're worth it, but they still introduce them here just in case. Here's another one. The amount is going to be $7,500. 1 plus 6% interest this time, divided by semi-annually, twice a year again. 1 year times twice a year. And they want just the interest, so we'll subtract back out the initial amount when we get to that point. So I have 7,500, parenthesis 1 plus 0.06 divided by 2, parenthesis again, raised to the 2 times 1, the second power. I get 7956. And then I can take 7956, 75, minus the initial investment of $7,500. 456.75 is my interest. 456.75. There we go, right there. This one does make reference to the table. Like I said, I don't know if it's worth the trouble, but we certainly could do it. But let me write it out in the formula. That's definitely an easy way to do it. Here again, we want the interest, but we'll do it by finding the amount and then subtract it back to the principal like we've been doing. So this is going to be, the amount is the principal, 18,000 this time. 1 plus the rate is 8%. Divided by, it's compounded quarterly, so it's 4 times per year. Now, 15 months, how many years is that? 15 months is 15 divided by 12, 1.25 years. So we have 1.25 years, and it's compounded 4 times per year. So that's what our calculations will look like. I expect this answer is going to be a few pennies different from the ones given, because they use the table, and the table has to round more than we do. And when you round, you lose a little bit of accuracy. It doesn't always amount to very much, but you lose some. So 18,000. Parenthesis 1 plus 0.08 divided by 4. Raised to the 1.25 times 4. Yeah, it doesn't want to do that. And I better put parentheses around my exponent to make sure it puts them in the right place. 19,873.45. So I invested 18,000 and I got 19,873.45 at the end. So my interest is 1873.45. You can see that one's off by a penny, but it should be pretty obvious where the answers are. Now, the bigger the numbers get, the bigger the errors get as well, but they'll never amount to more than a few cents. Like I said, you could use the table for this if you were dying to. They're listed on our Canvas site. At the bottom of all the modules is all the different tables. So table 11.1 would do that. I'm not sure it saves time like it did back in the old days. And so I embrace technology. I'm not too worried about tables anymore. We used to have to use tables for logarithms and trig functions too. We've pretty much gotten away from that. Okay, here's another one. $7,000. 1 plus 7% interest divided by compounded annually. So that's only once per year. 22 years times once per year. So that's just 22. Let's see here. 7,000. 1 plus 0.07 divided by 1. I don't need to write that in there. Raised to the 22nd power. Now, I imagine the error on this one's going to be a little bit bigger because these numbers are bigger. 31012. And see, we only invested 7,000 and it's now worth 31,000. Why so much? Because it was in the bank for 22 years. 0.81. So if you have, the table has little rounding, I think they go out to 5 decimal places, but even so, when you go out 20 years, those pennies add up. So anyway, we want to subtract the initial investment here and find out how much our interest was, and our interest is 24,012.81. Hey, it's only off a penny. 24,012.80. All right, number 5, 19,500. 1 plus 12% interest, which is 0.12 quarterly. That's 4 times per year for 10 years. So 10 times 4 is our exponent. $19,500. 1 plus 0.12 divided by 4 raised to the 10 times 4, that's the 40th power. 63, 609, 73, 74, I guess. Here again, another one with more interest, so we'll see how much difference that makes. 63, 609.74 minus the initial investment of 19.5. I get 44,109.74 for my interest. They want the compound amount in this case, so they don't care about the interest. They want to know the total amount. So we got 63,609 for that. 63, there it is right there. And you can see with these larger numbers, I had 74 cents. They have 59 cents. So it's actually off 15 cents, which isn't much when you're looking at $63,000. But like I said, that's rounding error on the tables. Use the formula. You're actually more accurate. Compound amount on a investment. Here we go again. So 9,500. 1 plus 12%. Quarterly, 4 times a year. 6 years times 4 times a year. $95. 1 plus 0.12 divided by 4 to the 6 times 4 is the 24th power. 19,311.54. 19,311.51. There it is. It's right there. Question 7. $8,500. 6% interest. Quarterly again, 4 times a year. 10 years. They want the total amount, compound amount. So that becomes 8,500. 1 plus 0.06 divided by 4. And 10 to the times 4 is our exponent, so that's 40. So 15,419.15. There it is right there. It's off a dime. We're all right with a dime out of $15,000. I can live with that. $8,000, invested $8,000 at 8% interest annually, 15 years. Compound amount, 8,000. 1 plus 8% It's annually, so it's just divided by 1, 15 years times 1, just once per year. So I guess that makes it a lot. It makes it like simple interest, doesn't it? All right, and we get 8,000. 1 plus 0.08, and I don't need to divide it by 1. I know what that is. And I'm raising it to the 15 times 1 to the 15th power. I get 25,377. Oh, they want the interest. I guess I should pay attention to what I'm doing here. But that's all right. That's just one more step. We take our 25,377, 35, and we subtract our initial investment out to find what the interest was. That's 17 or 25,000, right here. 25,000. 17,377. Right there. Calculate annual percentage yield of an investment at 8% interest compounded quarterly for 1 year. All right. Hold on 1 second while I grab the annual percentage yield. If you apply for a loan, they always list that on the paperwork. I don't know if anybody pays attention to it, but somewhere along the line, the government said they needed to do that. So they do. Annual percentage yield. That takes into account, so I guess it's more interesting if you're borrowing, because people wonder why they end up paying so much interest because of the compounding. They don't understand the compounding. This takes into account the compounding. So the annual percentage yield is going to be higher than if it's a 5% rate, the fact that it's compounded effectively makes it a higher rate because you pay interest on interest. So it's 1 plus the rate divided by the number of periods per year. And raised to the number of periods per year minus 1. Let's try that out. Didn't look too bad. All right, calculate $7,000 at 8% interest compounded quarterly for 1 year. Okay. My annual percentage yield is 1 plus the rate, which is 8%, divided by the number of periods per year. It's compounded quarterly, so that's 4 times per year. And we raise that to the 4th power, and then we subtract 1 from it. Let's see what we get. One plus 0.08 divided by 4. All that raised to the 4th power. All that minus 1. I get 0.082, which is 8.2%. 8.24, I guess. But let me see. 0.0824. Yeah, that's what I get. 0.0824 right there. So the $7,000, the amount that we borrowed doesn't even play into that problem when they're asking for the annual percentage yield. I imagine this will be another one like that. The yield, remember our annual percentage yield in this case is 1 plus, oops, 1 plus the rate, and this rate is 6%. divided by the number of periods per year compounded monthly. So that's 12 raised to the 12th power, and then we subtract 1 from that. One plus 0.06 divided by the number of periods per year, which is 12, raised to that power, 12. Then we subtract 1 from it. I get 0.0616 or 0.0617, which will be 6.17%. .17% is right here. Question 11. Interest compound. Calculate the compound interest for his investment. This just sounds like an interest formula, doesn't it? Simple enough. We invested $8,000. 1 plus the rate, 0.06 divided by semi-annually means twice a year. And then we raise that to the 1 year times twice a year. So that should do it. And calculate the compound interest for this investment. So that'll just be the interest is what they want. They don't want the final amount. So we have 8,000 times 1 plus 0.06 divided by 2. All that's raised to the 1 times 2 to the second power. 8,487.20. 487.20, and the initial investment was 8,000. So 487.20 is the interest. There it is right there. 4 more questions. Antonio invests $3,000 at 10%, compounded semi-annually 12 years. Use the interest formula. Will do. $3,000. The rate is 10%. The number of times semi-annually, twice a year. And it's for 12 years, and that is twice a year. So that'll be 24 as the exponent. So let's see here. 3,000 times 1 plus 0.10 divided by 2. And the power is 12 times 2, which is 24. So I get 96.75. So if I want to know how much of that is interest, 96.75 rounds up to 30 cents minus the initial investment of 3,000. I get 66.75. Let's see if that's what they were asking. No, they were asking for the compound amount. So that was the 96.75.30. 96.75.30. There it is. That's when they're asking the compound amount, not just the interest. I got to pay attention what I'm doing here. This person wants to have 18,000 in 1 year. Calculate how much she should invest now at 10% interest compounded annually in order to reach this goal. Now we're looking for the principal. And we'll have to solve that. We want to end up with 18,000. So we want our amount to be 18,000. And we're going to eventually solve for that principal, how much that principal needs to be. 1 plus 10%. It's compounded semi-annually, twice a year. and she wants to do it for 1 year. So it's twice a year for 1 year. This one takes a little bit more work. 18,000. Then we got to work all this out here to the right, so then we know what to do. So let me get back to my calculator. It is that stuff in the parentheses with the exponent is 1 plus that 10% interest divided by 2, all raised to the 2 times 1, all raised to the second power. So that is what goes here. 1 point, and I'm going to leave all my decimal places just to be on the safe side since it's not too many decimal places. It's that. So to solve for the principal, how much we need to invest to end up with $18,000, we divide both sides of this equation we have by that 1.1025. And that should give us how much the initial investment needs to be. So now I'm taking that 18,000 I want to end up with, and I'm dividing it by this 1.1025. 16,326.53. 16,326.54. Close enough. 2 more questions. All right. Can invest now at 8%. This is like the last question. We want to end up with, Jen wants to end up with $19,000. How much should she invest? How much should the principal be at 8% interest, compounded quarterly, so that's 4 times per year, in 12 years. So 12 years, 4 times per year. So let me calculate this stuff out here, and then I can solve for the principal. So I get 1 plus 0.08 divided by 4 times per year. And I'm raising that to 12 times 4, which I get 2.587. So that means that 19,000 equals P times 2.587. And I'll just round there. We should be able to tell what our answer is. So to find P, you divide both sides by that 2.587. 19,000 divided by 2.587, and that should give us the initial investment amount. 19,000 divided by 2.587. So it looks like if we invest 73, 44, 41 in 12 short years, we will have $19,000. And I already forgot that number, 73, 44, 41. 73, 44, right there. It's off by 15 cents, but that's because here again, they used the table. And we did do a little bit of rounding there. But it should be pretty obvious what the answer that they want. Here's another one, similar one, and our last question. The amount we want to end up with is $14,000. We want to know the principal. Our rate is 6%. It is compounded semi-annually, so that's twice a year, in 13 years times twice per year. So let me crunch all those numbers to the right of the P, and I get 1 plus 0.06 divided by twice a year, raised to the 13 times 2, that's the 26 power, 2.1565. So in order to, so that's reduced to 14,000 equals the principal times 2.1566, I guess would be the way it would round. Well, the decimal's a little messy there. There we go. So to find the principal, we divide both sides by the 2.1566 and see what we get. 14,000 divided by 2.1566. 64.91.69. 64.91.69. There we go. And that is that. That's the review for compound interest, the review quiz. And you should, if you can do all those, you should be just fine on the test.